We started working on navigation and force problems, but all we did was just set up the problems. What we're going to do now is actually look at what happens when two forces apply to a single point. Um, if you were to fly along in an airplane like this at 300 miles per hour, and there was a wind blowing this way at you at 40 miles per hour, if this was the place you were trying to get to, would you actually have to fly in this direction? If you did, what would happen is as you're going along this way, the wind would be pushing you this way, and you'd end up over here. And so what you have to do is you have to actually find a course that you're going to take so that as you're going along this way, the wind's pushing you until eventually you end up where you want to go. And what this is this is called the true course and wind speed that you'd be going. That's what you want to try and find out. So the type of problems you're going to be doing today will be ones like this. Suppose an airplane is traveling at 300 miles per hour on a bearing of 258 degrees, and a wind is blowing at 40 miles per hour on a bearing of, I don't know, let's say 112 degrees. Find its true course and speed. So what to think about what's happening. The plane is flying 300 miles per hour on a bearing at 258 degrees. Remember, bearing is measured from north going this way around the circle. Last time we talked about what you had to find is the direction angle. And that's what we're going to try and find right now. So we're going this way around the circle for bearing. Direction angle is this way. So if you remember, the direction angle for the plane here, the direction angle, let me make this a little smaller so it fits on here. There. Direction angle is 450 minus the bearing. So if you subtract that out, you get that it's 100 and, let's see, I can't do that in my head right now. 450 minus 258, 192. So that's 192 degrees. So 180 degrees was here. So really what the airplane's doing is it's flying at a direction like that at 300 miles per hour. The wind is blowing at a bearing of 112. So the wind, the direction angle is 450 minus 112, which is 338 degrees. Okay, so 338 degrees is going kind of like this. So the wind is blowing on it in that direction at 40 miles per hour. So what we do to find its true course and speed is we find like we did last time, you find the component form of each of them. So for the plane, the component form is the magnitude, which is 300, times the cosine of its direction angle, 192, and 300 sine of 192. For the wind, it's its magnitude, which is 40 miles per hour, 40 cosine of its direction angle, which is 338, and 40 sine of 338. What we do is we go ahead and we add these together, and we get the plane plus the wind. And that's what its true speed magnitude in that will be is we'll use this to find that. Okay, and so we go ahead and we add those together, and I just take my calculator and just do it on the calculator. I'm just going to add these two things together. So 300 times the cosine of 192 plus 40 times the cosine of 338. And I get minus 256.357. So I'll just write that down. Minus 256.357. And then I add these other two components, 300 sine of 192 plus 40 sine of 338. So you're just adding these components down is all you're doing. And we get minus 77.358. Okay, so there's the plane plus the wind together. After the wind's pushed on the plane, there's what it's actually, the horizontal components. It's going negative 256 and negative 77. Now make note that this is in the third quadrant because it's negative, negative. What we do now is find the magnitude of this. And if you remember for a vector, the magnitude of a vector, if it's a, b, the magnitude is the square root of a squared plus b squared. The direction angle is the inverse tangent of b over a, and then we have to put it in the third quadrant. Remember that we did this a couple lessons ago. To put it in the third quadrant, whatever the calculator gives you, if it's in the first quadrant, you use that. If it's in the second quadrant, you add 180. If it's in the third quadrant, you add 180. If it's in the fourth quadrant, you add 360. And so it's really just a matter of doing that using your calculator to find these things. So the magnitude of my vector is going to be the square root of this squared plus this squared. So again, I'm just going to take the calculator and I'm going to go the square root of negative 256 parenthesis negative 256.357 squared, oops, delete, squared, oh shoot, delete, squared, plus parenthesis negative 77.358 squared, enter. Oh shoot. Oh, I used the wrong thing. Negative. Now I do it and I get 267. So I'm going to write this down. Negative 256.357 squared plus negative 77.358 squared. And I get 267.774 miles per hour. There is the speed that the plane will actually be traveling. So the wind pushing on it back that way is going to be slowing him down. And that makes sense. Okay? To find the direction angle, what I do is I do the inverse tangent then of b over a. So it's negative 77.358 divided by negative 256.357. But because it's in the third quadrant, I'm going to add 180 to it. So I'm just going to do that on my calculator. Inverse tangent of, we'll do a fraction, negative 77.358 over negative 256.357 plus 180. Do it all right on the calculator, just like that. Hit enter, and it gives me 196.8 degrees. So that's its direction angle. The problem started out talking about bearing, and that's what we want to go back to. So all I do is to find the bearing is I just go 450 minus the direction angle, and that's going to equal the bearing. And if I do 450 minus my answer, I get 253.2 degrees. Oops, 253.2 degrees. 253.2 degrees. So my answer to the problem, it'll be traveling at 267.774 miles per hour on a bearing of 253.2 degrees. And that's how you answer the question, is on the bearing. So again, the process really is you find, if it's given as a bearing, you find the direction angle, write the plane and the wind in component form, just its speed times the cosine of the direction angle, speed times the sine. You add those together, and then what you do is find the magnitude of this, and that gives you the speed that you're going to be actually going. Okay? To find the angle, find the bearing, you find the direction angle. It's the inverse tangent of B over A. And then you make sure you put it in the correct quadrant by doing this little thing right up here. If it was in the second quadrant, whatever your calculator gave you, you'd add 180 to it. Okay? And so on and so forth. Find what the direction angle is, change it back to a bearing by subtracting it from 450, and that gives you the bearing, the speed at the bearing angle. And that's really what there is to finding navigation problems. Anymore, they use GPS for that, and that's variable and all of that. But this is the basic idea. And back in the 80s, when I worked on a tugboat, I went to sea school, and we had to actually calculate stuff like this in order to get my captain's license so I could drive the boats. So that was an interesting time. We did a force problem the other day, something like this. Three forces act on a single point. Force 1 is, I don't know, let's say 150 pounds at a direction angle of 112 degrees. Force 2 is 130 pounds at a direction angle of 237 degrees. And a third force is 155 pounds at a direction angle of, I don't know, let's say 72 degrees. Oops, I don't know why I put that. 72 degrees. And so we want to find, if we were to replace all three of those with a single force, what would it be and in what direction? And here's the idea behind what happens. If you have an object here, and if I were having a force that went this direction at, say, 30 pounds of force, and then there was a force this way at 50 pounds of force, you can see because they're acting in the opposite direction, this one's going to win out. It's actually going to be going in this direction, isn't it? Instead of going that way or going in another direction, it's going to go this way. But it's going to go at 50 minus 30, 20 pounds of pressure, or of force. Okay? And so kind of the idea is that's what we're going to look at. But again, you just like the problem we did before last time, is I'm going to take those and find component form for each one of them, and then we're just going to add them together. And so if we look at force 1, it's component form because we have direction angle, we don't have to change it. It's just going to be 150 cosine of 112, 150 sine of 112. Force 2 is 130 cosine of 237, 130 sine of 237. Force 3 is 155 cosine of 72, 155 sine of 72. All we're going to do is we're going to find a resultant force that comes from that. We're just going to add down and add down. So that's all you do. You just take your calculator. You could go ahead and calculate these out and then add the numbers together, but we can do it all right here on the calculator just the way it is. 150 cosine of 112. Just be careful with your parentheses. Oops, let me get the calculator up here where you can see it. We're adding these three together. So I'll cover up the other ones and then I don't add those. Plus 130 cosine of 237 plus 155 cosine of 72. And I get negative 79.096. So negative 79.096. And I carry it out to 3 places because that gives pretty good accuracy. There's ways on these that you could use the exact numbers, but it's kind of hard to go into that from here. Oops. And then to find the other component of my component form, I'll just add the other ones together. So I just take and I add these together. 150 sine of 112 plus 130 sine of 237 plus 155 sine of 72. And we get 177.464. 177.464. So that's the exact resultant of if I took these 3 forces acting the way that they do. If we replaced it with a single force acting on it, it'd go in the same direction. Okay? Again, the idea is if you had something here and you had an object pulling it that way, one pulling it that way, and a little force this way, it's actually going to move in somewhere in this direction, isn't it? Whichever one of these is stronger, it's going to start pulling it off in that direction. So if this was a stronger force, it would start pulling it off in that direction. Okay? All we're doing is finding the horizontal and vertical components of each one of these, the horizontal and vertical of that, adding the horizontal ones together, adding the vertical ones together. And that's all we're really doing when we do this. Now we find the magnitude of that. Magnitude of the resultant force is the square root of negative 79.096 squared plus 177.464 squared. Put that in your calculator, and we just go second square root, parenthesis, negative 79.096 squared plus parenthesis 177.464 squared equals, and we get 194.293. And that would be pounds, since that's what the forces are up above here. To begin with, we're in pounds. To find the direction angle, so for the direction angle, we make note that negative positive, that means this is in the 4th quadrant, down here somewhere. So what we're going to do is take, and we're going to, whatever my calculator gives me, it's going to give me a negative angle. We're just going to add 360 to it to come up with a positive direction angle. So we're going to go the inverse tangent of B over A and then we're going to add 360. Okay? So you just take your calculator and you just do that exact thing right there. Inverse tangent of, a fraction, 177.464, and on the bottom I got negative 77.096. oops, delete that, got to go outside the fraction to put my parenthesis, and then plus 360. And it gives me 293, so that equals 293.5 degrees. So my resultant force, my answer is it's going to be 194.293 pounds at a direction angle of 293.5 degrees. And that's what your answer would be. If you took those three forces right up here, three forces that we started with, and replaced them with one that would make the object go in the same exact direction at the same speed, this would be your answer right down here. That would be the single force. And those are the type of problems you're going to be doing this week. All right, so go ahead and look at the worksheet. Let me know if you have questions.